These are the prime numbers: 2, 3, 5, 7, 11, 13. They're the atoms of arithmetic, the building blocks every other number is made from. And they look completely, hopelessly random. There's no formula that tells you where the next prime will appear. But in 1859, a mathematician named Bernhard Riemann found something hiding underneath the chaos. A secret, perfect order. And astonishingly, the entire secret comes down to a single straight line. Prove that every clue to the prime sits on that one line, and you'll solve the most famous unsolved problem in mathematics and win $1 million. Look at where the primes fall. Early on, they're crowded together, 2, 3, 5, 7. Then the gaps start to stretch, unpredictably. Sometimes two primes sit right next to each other, like 11 and 13. Sometimes there's a long, empty desert with none at all. For over 2,000 years, mathematicians have hunted for a pattern, a formula, anything that predicts the next prime. And they've never found one. From up close, the primes look like pure noise. The genius of Riemann was to find a way to listen to them from a completely different direction. That direction is a function called the Riemann zeta function. It starts simple, 1 plus 1 over 2 to the s plus 1 over 3 to the s, and so on, forever. Riemann's leap was to feed this function complex numbers with an imaginary part, opening up an entire two-dimensional plane of inputs. And scattered across that plane are special points where the function equals exactly 0. Most of them are boring and predictable, but the interesting ones, the so-called non-trivial zeros, all seem to fall inside a narrow vertical strip. And that's where the magic begins. Here is Riemann's hypothesis in one sentence. Every single one of those non-trivial zeros lies on one exact vertical line, the line where the real part equals 1/2. That's it. That's the whole conjecture. But here's why it's breathtaking. Those zeros are not just dots. Each one acts like a hidden tuning fork, a pure frequency. And when you add all their frequencies together, they reconstruct exactly where the prime numbers are. The zeros are the secret sheet music of the primes. If they all sit perfectly on that line, it means the primes are as smoothly, evenly distributed as they could possibly be. No hidden clustering, no secret bias, the deepest possible order. So, is it true? Every test says yes. Computers have now checked the first 10 trillion of these zeros, 10 trillion. And every single one lands exactly on the line, not a hair off. Mathematicians are so confident that thousands of published theorems simply begin with the words, assuming the Riemann hypothesis is true. An entire wing of modern mathematics is built on top of it. And yet, in over 160 years, no one has been able to prove that all of them, the infinitely many we haven't checked, stay on that line. The $1 million prize is still waiting. So that's 20, and once again, math reaches the very edge of what it knows and stops. The primes whisper their secret along a single line 10 trillion times in a row and refuse to tell us why. Brain, 0. Math, 19. Round 20, still unsolved, still the most wanted proof in the world. Somewhere in those zeros is the answer to how the atoms of arithmetic are arranged, and it's just sitting there, waiting for someone to finally hear it. Subscribe, the whole streak is linked from the start, and maybe that someone is you.